Hello everyone, welcome to a new episode from our game development journey. Today we have a guest appearance, as you can see. It's a ducky keyboard. Ear of the bunny or the rat, I forgot. It's a it's an older keyboard I have. I wanted to change up things from time to time. I figured maybe you would like to see some other keyboards. Okay, I'm not so sure. So let me know what you prefer. But let's get on. Let's get on with this. This is what we had. We can now shoot the enemies. Nice. Now, do you know what we can do this episode? Oh, and I don't know if you observed, but we have a little animation, explosion animation that we created. Well, we didn't create the animation, we created the concept of an animation in code, but the animation was created by someone else, obviously. Okay, let's create today, maybe, an enemy spawner or something. Let's see, I'm talking to the correct microphone. I am. Okay, I don't want to waste like an hour of time talking nonsense here and no one hearing me. So we actually have an enemy here, whatever. This is based on time, we can remove that. This is like a basic enemy. This is the thing that actually is on the screen. So we should actually, let's see, we should have our stuff here. In the enemies, we have this Alan, we have a Bonbon and Lips. So let's actually create a separate enemy class called Alan, okay, and we will inherit from this enemy. And the movement will be, custom to that enemy and so on. So enemy Alan, okay. And I'm simply taking the name of whoever created the pack. Why not? Let's honor them in that fashion also. Alan, enemy Alan, and we will say, I have to get used to this keyboard now. I didn't type on it for a while. It's an enemy. Oh, and also I have my headphones on, and if I talk with them on, you might not hear me as well. So I quickly revert that. Let's include here enemy, just like that. And let's do that. Let's quickly create a simple constructor. Nothing new, really. And we also need, if we go in enemy, enemy dot, oh, and again, this is a CPP in the headers, which is completely wrong. Well, I mean, you do it however you want. I'm just telling you how it's usually being done. So actually I could copy this whole thing, but basically, now this is just a shitty game that we are making, a really small game. I'm not, so we should take this animation out of here, by the way. Put it here because it's something specific to Alan. Okay, other enemies might not have an animation, and this texture will also disappear from here. I'm just keeping it here. I don't know. So technically, we should make a nice way for enemies to move. But what I'm thinking is we shouldn't care so much. I mean, it's just a small game. We could just hard code their behavior for each enemy since we only have 3 of them. But in the future, if we work more interesting projects, we might explore that option. So we know we have to change this on outside scene and on collision thing. Potentially, I'm not so sure about the on collision thing. This actually isn't doing anything. So that's about that. This receive death. you know, when you die, this should also be something virtual. But we have the basic implementation in here. We just spawn in an explosion. We need to re-implement these. Where it's this one here, let's keep it there. So we will have to re-implement those. I think on collision we don't have to do anything for now. We would also have to remove some stuff from the enemy class, but for now this is gonna be enough. So enemy ln.cpp, I'm simply gonna copy this. Oh my god, I can't see anything. I have to look at the OBS stream to see what I'm typing there. I have to move the camera somehow, or maybe like I could. Okay, nice. The like Visual Studio got stuck there. I could move it here like that, but I think that gives you like a worse experience. So I'm just gonna, you know, let's move it here actually. Okay. So this is the CPP file. I'm obviously gonna remove this. Not everything. So I'm gonna append the scope. Just like that. Okay. And I also have to do here enemy Alan. Alan at your command. Guys, did you know I'm also a certified dork? No, I meant voice actor. No, I'm kidding. Okay, I'm kidding. I'm kidding, guys. Okay, I can put it here because I'm not writing code in it now. And this is what? What's the problem? Alright, this is an enemy. Enemy scene, starting position. That should be it. Okay, let's see what's the issue. So no instance. Let's see. You might actually be wrong. We actually have this here, but either way, we also have to copy some code over. So this idle stuff, we have to initialize it in here actually. We also have to include the assets. We need to take all this out of here, like that. Oh, I might know what's the issue. I'm gonna take care of it in just a second. Let's copy the whole render function actually. Take it out. Just like that. Yeah, whatever. I'm gonna keep it there for now. This should be all. Now, let's see. It complains about a lot of stuff. Like, it doesn't know. It's inaccessible. Okay, that explains it. So, enemy. Yeah, this is private. And we don't want that to be private. We want that to be... please never send me a notification again. Thank you. Okay, let's remove the texture part, I guess. So we made them protected, all good. Enemy, for some reason, oh, this is actually a pointer. That's a mistake on my part. Well, every mistake in here is my part anyway. It's because of me, because I'm writing the code. Duh. And so now in app.cpp, we are actually, instead of including the enemy here, we can just include enemy Alan, which is a specific enemy. And here we put enemy Alan. And when we run this, oh my god, we have the same exact thing. So, okay, we killed it off screen probably. So let's actually make them move side to side slightly faster. Let's see, where did we decide that? It was on outside scene, I think. Oh, that's the issue actually. I forgot to copy the code from on outside scene. So now when it exits the scene, it doesn't revert the x axis of the direction, the x component. So now it should move from side to side, and it should move a little bit faster. We should put it like 10 at least. Let's see how it moves. Okay, that seems pretty okay, I guess. And let's make it move down slightly. Okay, so it's gonna move down. And here I'm setting the direction somewhere. Oh, we also, at some point, we will have to change these bounds, maybe. Not necessarily because all the enemies have the same size, but, you know, just saying. So let's copy that. Actually, M direction should be something very specific to our enemy. So actually, enemy shouldn't have direction stuff in here. We should also not have that. We should not have... I think that's it for now. So M direction, obviously it doesn't know what it is now, so let's add it in. We have it, 1, 1. However, now it's gonna move down with the same speed it moves. You know, it's gonna move like, yeah, like that. So on diagonal, we don't want that. We want to move down slightly, not as fast. So like a tenth of the speed it moves left to right. And you know, this is, you know, an alright way to do it. You know, like now it does that, and we have to dodge a little bit. Maybe even slower, like make it 0.04. And now we have that. Nice. Good. Now the enemy is actually moving down. We have this this code here. We keep it here because we might want to copy paste it at some point. If not, we can just clean it up and remove it entirely. Okay, but let's create actually something that will spawn these enemies. So let's create a new game object that will be in the scene. It won't have a texture, it won't have anything, it will only be used for the ticking. So once every few ticks, it's actually gonna spawn enemies. Okay, so enemy spawner .hpp, don't forget. And let's do that, include game object enemy spawner. Okay. We are only going to initialize it with the scene. We might want to pass in some stuff in here, like what enemies we want to be able to spawn or some stuff, or we might want to decide that later on. Well, for now I don't plan on adding like levels to this, just like endless enemies coming probably. Like coming over, I meant. Okay, I'm gonna stop talking now. We have virtual void peak in here. Delta time, obviously we're gonna override this bad boy. Yeah, buddy. The render function is actually gonna be empty. And you know what? We should make it empty, like possible to be empty by default. So in here, our render function, it doesn't have to be like that. It doesn't have to be pure virtual. We can just make it virtual. And okay, here, my bad. So in here, we can just add this, make it, you know, empty, and now we don't have to implement it in classes that don't have anything to render. So we write even less code now, theoretically. I mean, this is still C++, so we do have to write quite a bit of code, I guess. Yeah, you know. Okay, so this is the enemy spawner. Nothing too major here. We will write more code in here at some point. Let's create a source file, enemy spawner.cpp. Let's see, enemy spawner. Nice. Now it's a bit hard to type in here because of the stuff I was mentioning, the camera, but I'm gonna manage, guys. You know, I'm a professional. That's not gonna stop me from making a shitty game. So scene, and we can pass in whatever for the position since we don't even care. And we could actually, you know, if we actually care about our game and performance, and we would have multiple objects that don't have to be rendered on the screen at all, and we don't care about their position at all, we could have like a separate category of objects that are not renderable, and they won't even be included for rendering. But you know, I'm just telling you how you might want to do that. You know, you can make it with a flag, or you can just make separate lists for that. Maybe you don't want to make this as a normal game object, you want to make it like an unrenderable game object, and the scene would have multiple like separate vectors for those. Hey, you do you. I'm just telling you what things you might want to change if you want to expand on a similar architecture, I guess. So what we are going to be doing now is I'm thinking we should have like an like a list or a vector of, well, not a list or a vector actually. We should be able to add maybe to a map by name. We basically want some sort of factory, right? So we want to spawn a mob, but we want a class to create that mob instance for us, the like enemy Alan, right? How we are creating it in here. We want a way to do this at runtime, and we have multiple ways of doing it, really. Like we can have like a stupid switch case if we actually want, but I'm gonna show you like one way you might want to do it, and you know, you can choose whatever you want to do. You're here to learn probably, or not, I don't know. So yeah, enemy factory could be okay. And we can have like a function here called create, and we would pass in here the name. So string name. Okay, and we're going to implement this at some point. We have to implement or just briefly mention the enemy, but it's okay to just include it now. No one is going to get hurt. Okay, we have this create function, and what's going to happen is we have somehow to know how to create this object. All right. So again, we could make it with a switch case saying, I'm going to show it. Maybe it's easier to show you. I don't want to make it foggy if you don't understand what I'm saying. So I'm just simply gonna do that. So what's gonna happen is here, well, we have a name here, but yeah, well, we could theoretically, and this is a completely fine implementation, by the way. I mean, if your game is not a really big game, there's really no good reason why not to do it. Like if you have like 20 enemies, yeah, it's pretty bad, but it's not the worst thing you can happen. It's not like under a simulator level of worse, okay? So you could say here, hey, if it's like Alan, so the enemy spawner chose to, you know, spawn Alan, or maybe this is gonna be like an ID, like int ID, and you know, this could actually work. So you could pass in an ID here, and well, in this way, this is, well, the better way to do it, by the way. I'm just giving you examples on how you might want to approach this. So if it's the ID, you can do, hey, case enemy IDs, which we don't have yet, but I'm just, you know, giving you an example, Alan. And so if the ID is Alan, we're gonna return new enemy Alan, blah blah blah. Okay, so we can do that, but I'm gonna show you maybe a bit of a more sophisticated approach, so you don't have to have this switch or a bunch of ifs in here. But again, these approaches for small games, no problem. Okay, if you are planning to do something big, The switch might be okay actually. There's no reason actually why the switch shouldn't be okay in here. Because the switch is actually using like a jump table, and it simply jumps to the location where you want to execute code. And yes, it's not as fast as what I'm about to show you, maybe. This is not tested, by the way, so take what I'm saying with a grain of salt. You have to document this yourself in order to be sure. Don't take what others are saying, for granted. You know, try to implement it your own, right, in your own way. Test it, see, hey, maybe if I implement it in this way, it's better. Implement it in the other way, test it like that, you know. This is what you should be doing, but yeah, whatever. Just giving some common example, some common advice. So in here we also need the scene, because we have to pass in the scene when we are calling the constructors. And I'm going to show you a way to make it without ifs and switches. And the answer to that will be, we will have a map actually. You don't need a map. You can do it with an array. You can do it with trees. Well, let's not exaggerate now. Yeah, you can do it with whatever you want. The point is, you need to be able to identify the enemy by the name or by the ID. I'm going to use the name here because it's, I don't know, sort of more intuitive, I suppose, but an ID would work just as fine. And oops, the string, the key in our map will be the string. And here, this is actually what I want to show you. We will have actually a function in here. We will have a function pointer, and this should be like, I don't think I have to do it actually this way, but enemy pointer, and it takes in an scene and a position. This is what all enemies are taking, and this would be like the enemy map, enemy creation map, I guess. The point is, we are going to use a map in order to redirect us to a function that will actually create this enemy pointer for us, just how we are doing it in here. Okay, so let's include the map and put it up here. And whoa, it actually compiled. That's actually amazing. So let's do this. We also obviously have to initialize this entity factory somehow, so let's do that. We're gonna have like initialize, and we are gonna pass in here all the functions for creating the enemies over here. So let's actually let me show you what that would look like, so you can go on and expand this on your own. And this, by the way, this is used, you know, I'm not showing you some obscure way of doing something. You could very well find such things in production, in, you know, games or other types of software. So this is not something weird you should be afraid of implementing somewhere. This is actually usable. Okay. So we have here, we have this Alan. Okay, and we are gonna, so what we could have here is like a static, well, a void create Alan function. Okay, and we would take in the scene pointer and the v2 position. Okay, and it's gonna return an enemy pointer. Let's do that. Okay, for now we return null pointer, and we could theoretically do that, I think. Yeah, so this works. So whenever we call enemy entity map, we want to find the enemy by the name, and we want to actually call the function, right, we call the element from the map, which is a function, it's gonna call this function, okay? And we have to pass in the scene and the position, which I forgot to give. So position, okay. Maybe some enemies don't require a position, but yeah, we don't care about that now. Yeah, it's okay. Position is the starting position anyway. And voila, we can actually do it in this way, okay? But what I want to show you is that you don't have to create a separate function for that, because you will just write more code for nothing. You can just do, you know, this, okay? Return and this function actually takes in 2 pointers like that. Scene, position, let's call them P and S. New enemy Alan, and let's actually include, maybe we shouldn't create the enemy factory stuff in the same source file as the enemy spawner, but for now we will survive with that. And here we can do S and P, and voila, this is what we did with 2 functions. We now only have a function that does it, and it's extremely small. And whenever you add more enemies, you just do this, okay? And you initialize them whatever, you know, however you want, okay? And you can obviously make these enemies have like a certain difficulty threshold, like you only spawn them if the game is above a certain difficulty level or something. You know, you can make it, you know, way more complicated. We can initialize this enemy creation map with more stuff, not just a function that creates the enemy. It can also keep like the scenarios in which you want to create the enemy, which should actually be decided by the enemy spawner if it should be able to spawn that. So yeah, maybe you wouldn't want to put it there. You might want to put it in the enemy spawner. But for now, whoops, man, I'm gonna kill my microphone one day. I keep on hitting it. We have this. This hopefully compiles. Oh damn, I should bet whenever I know the code won't compile. So create doesn't return anything. Yeah, it should return whatever this function retrieves. Obviously now if you want some basic error handling in here, you should check that our enemy creation map actually contains this name, this enemy name. So we could do a little check, I suppose, so people don't say I don't do it. Well, people won't say anything, but you know, it's good to have it there, okay? Else, you know, don't throw a tantrum, just return null pointer, okay? And we will check if it's null pointer. So this is it. Let's create an instance of this enemy factory. Over here, enemy factory. You could also make this like a singleton, since it's a, you know, a factory. Maybe it makes more sense for this to be a singleton. So like these should be static, so you can call them from anywhere. But I mean, it's okay for now. We can change that later on. Okay, in here, when we create this enemy spawner object, we actually initialize this enemy creation map. So the functions responsible for creating the enemies. Okay, and what we need now is like a timer. And well, I'm just showing you a basic way to spawn enemies, I suppose. And we advance it by delta time, and we say, hey man, if this time is longer than 1 second, we reset it to 0, so we count again, and we will, you know, we will spawn this enemy. And Let's put it in a different function, like spawn enemies or something. Let's take it, put it here, just like that. Let's call this function in here. And what we are going to be doing is simply spawning like one enemy. And we can only spawn Alan anyway, so that's that. I'm not going to take too much out of your time. We will have an enemy. We will create for now using scene. We have to spawn position. We will determine the position where it has to be spawned. And the name of the enemy, which for now we will simply give Alan because it's our enemy, our only enemy. In the future, we might want to create here a vector with multiple enemies and randomly choose. That's probably what we are going to be doing anyway. So here, this is by the way in the enemy factory, like that. And we only have this spawn position to resolve, which is going to be, we want to spawn things outside of the screen. So I think -64y, it's okay for now. And the position could be random. I mean, I'm gonna do something horrible now. I'm gonna use rand. And we actually need to know the screen resolution for this. Now I'm gonna cheat a little bit so we don't make this video longer by writing more code in order for us to make this actually accessible. But I'm gonna say like something like this, which is the width of the screen. Okay, again, please don't use this. This is pretty bad. This is actually not even correct. Not even correct, is it? Yeah, we have to do -64 in here, and we have to add in here 64. But yeah, because if you think about it, TL draw, what happens is we have the scene and we are spawning it somewhere in here up, right? And when we spawn it, if we do a modulo with the screen width, maximum it can hit, like give us this point at the edge, right? Like something in here. But so our enemy won't actually be visible, which is okay. When it goes down, it's gonna move this way anyway, but just saying, it will be outside of the screen. But in here, it won't be able to spawn outside of the screen. So we want to push it back, actually, so it reaches the outside of the screen here also. So it gives the same impression when it's gonna move. You know, it's gonna make this possible for the enemies to move in these directions like that. Otherwise, only this enemy will start like that. I hope it makes sense. I just want to make that equal. So I simply added 64 more when we do the modulo, and then we subtract the 64. So if this hits 0, it's gonna go -64 in the x, which is the width of the enemy. Well, you can experiment with that and see on your own what changes and what not. I recommend you do that in order to fully understand what's happening. So let's actually try to do that. Let's remove our enemy Alan. Bye bye, Alan. Bye bye. And we do add enemy spawner, which we don't have because we didn't include it. Enemy spawner. And let's remove the enemy stuff from the main for now. By the way, we will rewrite this at some point. We want to put this into like some special game scene thing, you know, not in the main. But for now, you know, it's good for testing purposes. Obviously, we are not shipping this anyway, at least not for now. So yeah. we added that. Let's try to run it. We have, oh my god, they are all okay. Someone is outside of the screen, by the way. Oh my god, this game is actually playable now, somehow. We still have this enemy here which is stuck. It should have, maybe it spawned too much. So, too much to the right, and so it's stuck there and it can't move. I forgot if I put like a restriction of movement on outside of the scene, but yeah, I mean, it works pretty well, not gonna lie. Let's not do the +64 thing. Let's do something else. And this is pretty bad, but I mean, we use rand for random generation, which is already bad, but yeah, random x. We do that, and we have a very specific condition. So if this is 0, we want to put it on the edge. Otherwise, just let it be random. And if it's on the edge, oh no, actually this is enough. So we only push it towards the left if it's completely at 0, which again, it's not symmetric. This is pretty bad code, but it will do the job partially. But yeah, I'm just writing something quick and easy to use. So now it shouldn't be stuck outside anymore. We don't have one yet, which is pretty nice. We might want to make them go down slightly faster. Now this is game balancing, really not engine development, but let's just do that. Let's go into the tick and let's say the speed. So we want to go down a little bit faster. Let's bump the number a little bit. Okay, let's see. So we have them coming over. So let's do that. Nice. Okay, this is better than what we had at the beginning of the episode. So you know what it means, guys. You have to subscribe to this channel. Yeah, hit the ring, 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 ring. Ring the bell. Don't forget the bell, guys. And that voice crack was from the abyss. Okay, in the next episode, I don't know what we are going to be doing. We are going to add more enemies, maybe, with more interesting movement patterns. Maybe. I don't know. Stick around and find out.